In this problem, we are modeling a hyperbola or nuclear power plant cooling tower using hyperbola. So the sides of a nuclear power plant cooling tower form a hyperbola. The diameter of the bottom of the tower is 281 feet. So that's how far it is across the bottom. And then it says the smallest diameter of the tower is 135 feet. So that's going to be that transverse axis right there. And that's going to be 428.5 feet above the ground. And the tower is total 581 feet tall. That 581 kind of throws you off because it's not really used in the problem. So we want to find the width of the tower when the height is 227. So in essence, what we're going to come up with is something of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. And then what we'll do is look at it and say, okay, when y equals 227, what is x? And you got to be kind of careful when you put these in the calculator, because I set it up right, but I was fighting with the answer here. So let's go ahead and model this. And I was going to draw on it, but I think it just, this iPad notes thing gets a little messy when you do that. So one way, and I believe this is going to be the best way to model this, is if you set your axis system such that, like, this is along the x-axis down here at the bottom, and then this line of symmetry goes to the y-axis. And it's not drawn very well, and I apologize. Anyway, so here's this middle line. So here's our transverse axis. By doing it this way, we have the h equals 0 for the hk, but the k is going to be this value to 428.5. So we have x minus 0 squared over something minus y minus 428.5 quantity squared over something equals 1. And we already know this x, what goes under the x, we know the a value because it's 135 across. And 135 divided by 2 is 67.5. So this is going to be 67.5. What we don't know is what goes under the y, so we don't know the b squared. So we have to find that. And fortunately, we know a point here. We know the width at the bottom is 281. So if the whole thing across is 281, 281 divided by 2 is 140.5. So that means this 140.5, getting a little sloppy here. So this is the point 140.5 comma 0. And it's interesting the way that this program has set that up. In the previous problem we did with the parabola, actually I think it comes later because I think it's 11.3 topic. But they like to set up an axis system to where the center of the vertex is not at 0, 0. Because it makes it easier later on if you can set it up so that zeros for one of those points. But I digress. So what we're going to do is going to plug this into the x and the y, and we would have 140.5 squared over 67.5 squared minus, then 0 minus 428.5 squared over b squared is 1. So we get to play the algebra here, and let me get to the right page of my notes. So obviously the unknown is here, everything else is known. So you'd subtract the 140.5 squared over 67.5 squared. Not sure why I did the parentheses there. And the previous step, 140.5 squared over 67.5 squared. So we end up with like negative 428.5 squared over b squared equals 1 minus 140.5 squared over 67.5. Again, we're trying to solve it for this b. And, I almost think it's worth just several things and working this out. And it's late at night and I'm tired, so I'm going to look goofy here. If I multiply those out, and then now I have a number times b squared equals a number. And then if I divide by this, 1 minus 140.5 squared over 67.5, forgot the squared there. Divide this by 1 minus 140.5 squared over 67.5 squared. And what you end up with is our b squared, which is all we need. We don't need b, we just need b squared, is 55,096.37. And I verified this on a certain program. I'm not going to name it because it seemed kind of big, but that does work out that way. So we end up with x squared over 67.5 squared. I didn't multiply that out, but just because in calculations, whatever, it'll work itself out. Y minus 428.5 squared for the whole quantity there over 55096.37 equals 1. So now we're going to put y equals 227 because we want to know what x is for the width. That'll tell us just half of the width, by the way, how far from the central line it's going to be. We're going to double that to get the overall width. So we're going to put this 227 in because that's the height. And we'd have x squared over 67.5 squared minus 227 minus 428.5 squared over 55,096.37 equals 1. So it's x squared over 67.5 squared equals 1 plus that 227 minus 428.5 squared over 55,096.37. And then I want to multiply both sides by the 67.5 squared. So x squared is going to be 1 plus 227 minus 428.5 squared over 55,096.37 times 67.5 squared. So x will be the square root of all this, 1 plus 227 minus 428.5 quantity squared over 55,096.37 times 67.5 squared. I'll put another parenthesis here. And what we get x to be is, really excited when this worked out, 88.96. So multiply that by 2 to get the whole distance, not just half. And we get 177.92, which is the answer. Yay!